have a rational number, then followed by the next alphabet, which is Z. Z, we call it integers. Integers. Then we have W, which stands for whole numbers. Then we have N for no, N, which means natural numbers. Then we have the last letter P, which stands for prime numbers. Okay, this is actually the acronym, but in this next video, or rather, let me just finish everything here. Let me give you a brief explanation of each and every one of them because this is a history I'm trying to deal with here. So coming to the first one, which is complex number. Complex number is actually a number system that has two numbers, a real part denoted with A and an imaginary part denoted with B. But I always explain to my students that this part that has I is not limited. It's not always that the imaginary part should be B. It can also be something like this, like in real life now. I can have 2 plus 3i. Where's my imaginary part? The 3. I can also have 3 plus 2. Then my imaginary parts will come to 3. Like I'm having 3i plus 2, all in bracket. It means my 3 is the imaginary part. So I'm only mindful of which part of my mathematics or of my calculation has I. That's my imaginary part. That's all. As simple as that. Then I have my real part or my real numbers, sorry. The real number simply denotes any number at all that appears in the number line. In the number line system, you already know what your number line is. It has 0 and here is positive infinity and here is negative infinity. So what can I say in my number line? 1, 2, 3, 4, 2 billions. Yes. In the negative part to negative 1, negative 2 to negative infinity. All those numbers are in my number line. They are the examples of real numbers. But can I see something like 0.5 in my number line? No. Even though I know it do exist, but I can't see it. So they are never an example of a real number. They are numbers that are real. So in other words, I'm trying to say that I can never see decimals in real numbers. But I can see a lot of whole numbers ranging from negative to positive. That's it. Okay, going to rational numbers. Rational number, just like the name inclines, ratio, a number that divides, just like in our primary schools where we do hear about Simbi and Obi. They say Ali and Simbi shared 30 oranges in the ratio of 2 is to 3. You understand now? In a ration, another word for ration is actually fraction. So I can also say that the examples of my rational numbers are 1 over 2, 1 over 3, any fraction at all. And you know, most occasions, 5 whole number is the same thing as 5 over 1. I hope you understand because there's an imaginary number under this 5. So that's that. But that's not the case study now. I'm just trying to make you to be familiarized with each and every of these names I've mentioned. So now I believe you have a glimpse of what rational number is. I'll still go in details with each and every one of these numbers or this number line. Sorry, of these number systems I've listed out here. So I'm done with rational number now. Then irrational number. Irrational example of irrational numbers are sorts. They are numbers that are a standard number. They are defined. So what do we mean? Sort, something like root 3. You know what is sort now in mathematics? Root 3 root 5. All these square roots that cannot be a perfect square, they are sorts. Yeah. Then something like an example like uh, pi. When you hear of pi, is a standard number, is a defined number, and the value for pi is 3.142. So wherever you see pi or you see 3.142 or you see 22 over 7 is actually an example of irrational numbers because you can never see it any other place. It's a defined value. Just like in physics too, gamma, alpha, beta, those terms they are defined. They have their specific number, just like speed of light. It has a specific number, stuff like that. Then integers.